All right, thank you all for being here today. We are Clean Water Consulting, and we're excited to present our proposal for the Crow Wastewater Improvement Project. So I'm going to quickly go over our team organization. My name is Ryan Carney. I'm going to be the project manager for this group. We also have, to my left, Michael Wetterow, to my right, Ben Koosman, and Crystal Gibaragous. And together we have expertise in the areas of wastewater treatment, environmental science and monitoring, and sustainability. Now, quickly, I'd like to go over what we're going to be presenting today. So, first, I'm going to be going over a background of the Crow tribe and just talking a little bit about them and the problems that they're having. Next, we're going to go into our problem statement and also present a few of the alternatives that we've looked at, which we're going to be looking at more in the future. Next, we're going to go into a revised scope, which Mike will talk about in a little bit. We'll talk about the decision process and the timeline and budget of our project. And at the end, we'll have a period for questions.
So yeah, here's a little background on our project and our clients, the Crow Nation. So the Crow tribe, they live on the Crow Reservation in south central Montana. It's that red area right there. There are about 6 major towns on the reservation, but we are going to focus on the town of Crow Agency. And the issue of water quality is a bit of a concern on the reservation. And in the town of Crow Agency, their wastewater treatment systems have been overworked and in need of repair. And the Crow people traditionally employ traditional use of water, such as they use the local springs and rivers for things like drinking water and bathing. And because of inadequate water treatment, wastewater treatment, the people are exposed to harmful bacteria that cause health issues such as stomach ulcers, other stomach issues, and diarrhea. And so, yeah, that is an issue on the reservation. So based on the request for proposals, these are our project goals. We plan to evaluate the current treatment system and see what's wrong with the current treatment system that's leading to these water quality issues. And because the Crow people are so involved with what goes on their reservation, we plan to work closely with them to make sure we are complying with their ideas of land usage and water usage. Then we're going to assess suitable alternatives to provide a solution to their water quality issues. However, first we need to build a respectful, trusting relationship with the Crow people, and we plan to do this by keeping in constant contact with them and making a trip up to the reservation as a team.
All right, so currently there are regulations in place for what the Crow can actually discharge into the Little Bighorn River. And this actually falls in place for all Indian reservations that use lagoon-based treatment in the state of Montana. And so currently they have to keep BOD and total suspended solid levels below 30 milligrams per liter for a 30-day average and 45 for 7-day average. And they also have to keep it in a range of between 6 and 9 for pH. And oil and grease levels can't exceed 10 milligrams per liter. All right, so their current system right now is they have 3 aerated lagoons, and the way it works is that the wastewater enters the aerated lagoon, and then it's discharged into the river. And it's been recently constructed, and the blowers have been recently upgraded. And there are problems with during the winter months when biological activity is slower and does not actually treat the wastewater properly. So what's being discharged into the river is not, it's not exactly the most clean or healthy water. All right, so what we were thinking of doing was adding disinfection to right after the aerated lagoon. And we were going to do that, examine the UV, ozone, and chlorination as potential methods. Chlorination and ozone destroy harmful cells by oxidizing the cellular material, while UV destroys the DNA and the cell's ability to replicate. And when we choose one of these technologies, we're going to look at the wastewater characteristics that are actually coming out of the aerated lagoon and how it could affect the disinfection process. And we're we're also going to look at the relative cost between them. Currently, chlorination is cheaper than UV and ozone, but if there's a need for dechlorination, that will make UV and ozone competitively priced with chlorination. Another thing is going to be looking at the ability to operate in cold weather and the byproducts given off by all disinfection processes.
So another alternative that we're looking at is constructed wetlands. So natural wetlands act as a biofilter and they naturally remove sediments and pollutants from water. And constructed wetlands are designed to emulate these features. And so there are two main kinds of constructed wetlands: surface flow and subsurface flow. In surface flow wetlands, the water flows over the top of the soil, just like in natural wetlands, and it goes over a vegetated soil surface from an inlet point to an outlet point. And the difference is with the subsurface flow is for that the water is designed to flow below the top surface of the soil, and this helps with things like odor and mosquito breeding. The main advantages of constructed wetlands is it's less costly, it's environmentally friendly, and the main disadvantage is that it probably uses up a lot of land compared to other wastewater treatment systems. But on the Crow Reservation, they have quite a bit of land, so this will not be an issue.
Another treatment alternative we investigated was installing an anaerobic lagoon before their existing aerobic lagoons. This process works where raw waste is input to the system, suspended solids settle out, while microorganisms break down organic matter into methane gas. In this process, we would probably attempt to capture the methane gas to make it sustainable and use this for either heating of other processes or reuse in the energy sector. This process is also very sustainable because there's low capital and operations and maintenance costs. There's no need for aeration, mixing, or heating in this process, and so the O&M cost would be very low. We're kind of tentative with this process because microorganisms don't function too well below 20 degrees Celsius, and being in Montana, the temperatures are very cold in the winter. However, low temperature anaerobic digestion is being studied right now, and it's proved to be successful at laboratory and pilot scales. Another alternative we looked into was replacing the whole aerobic lagoon system with a mechanical wastewater treatment plant. This would follow an activated sludge process where we go through preliminary treatment, primary treatment in a settler, secondary treatment with an aerobic digester and a secondary clarifier, and the sludge from the secondary clarifier would be recycled to the beginning of the aeration tank to ensure the micropopulation is high enough to effectively break down the waste. And then the sludge from the secondary clarifier and the settled sludge from the primary clarifier would be sent to sludge treatment, which would be an anaerobic digester. Once again, this would produce methane, which we could reuse as energy, and also biosolids that could be used in land application. Some of the disadvantages to this process are it's very expensive, both capital costs and operations and maintenance costs, because almost every stage of the process requires mixing and heating.
So we redefined our project scope after visiting Crow Nation and Crow Agency. So what we were thinking is that we go from wastewater treatment to water reuse and have it be treated to a point where it can be applied to either agriculture or industrial or groundwater recharge or even to the environment. So it would put an overall less strain on their watershed, and it's just a great resource that you can use. It could also decrease costs in drinking water. So right now, what we were thinking, alternative for water reuse would be we have the aerated lagoon, and then we'd either go membrane filtration or granular media filtration, and then once again disinfection either by UV chlorination or ozone. And what things that we're going to be looking at is what are we going to actually apply the water, the reused water to, because EPA, even though the Crow Nation's self-governing, EPA has a guidance and actually regulations of certain levels of treatment that must be met in order to apply the water reuse, and that's going to be a huge factor of picking what type of, filtration and disinfection that we need.
Okay, so prior to using a decision matrix to choose an alternative, we're going to run our alternatives through project constraints to make sure they actually fit the specifics of the site. Some of these constraints include available land area, capital costs, it needs to be less than the provided budget. The community needs to be able to operate the machinery rather than having to bring in an expert to maintain the technology. It needs to be appropriate for the community loading rate. Since it's a relatively small community, there would be a much smaller loading rate than any industrial wastewater processes. It needs to be able to perform in cold weather, and it needs to be able to meet standards for water reuse. Our main goal for this project is to meet the Crow's needs for wastewater treatment and make sure they're happy with that technology. And to do this, we will maintain constant contact with the Crow and try to get their input as much as possible. One of the ways we will receive their input is in a survey where we will ask their relative importance for these different decision criteria for each of the alternatives. As you can see in red, we added a couple after we redefined our project scope. And we will score each technology on a scale of 1 to 5, 5 being the best fit for the technology. And by scaling this by the relative weight, we will be able to get a final technology score and rank the technologies.
So here is our proposed project schedule. A couple major points that we have on here is March 14th is our alternatives assessment submittal, and that will be looking at the basic alternatives that we've identified that could work for the Crow Nation, and also recommending one of those based on the decision matrix. April 30th will be the presentation of the preliminary design, and that will be a 30% design of the chosen technology. And here's a summary of our project budget. As you can see, we are all working approximately 90 hours on, to complete this project. And I think that's a bit atypical for this kind of project, but we're doing that because of the limited time scale. And at the bottom you can see our estimated fee through the preliminary design phase is $22,400. We're going to be using a strict quality control method. It's going to be an iterative process, which means that we'll go through this cycle several times before we are satisfied with the final product. First is going to be an individual assessment period where we will look at our own materials and make edits as necessary. Next will be peer assessment and supervisor assessment through Dr. Linden and Dr. Bielfeld. And we will go back into the individual assessment phase to make any edits to that. Just a quick recap of what we covered in this presentation. We went over the background and a little bit about the Crow Nation problems that they were having with their water quality. We looked at the alternatives, the initial alternatives that we presented to them. Talked about redefining our problem scope and going through the decision criteria that we will be looking at and the project schedule. We'd like to give thanks to the Crow Nation for an opportunity to present our proposal to you. Tom Bowen, thank you for coming. And at this time, we'd like to ask for any questions if you have any. Thank you.
First of all, I want to thank you for your expression of cultural sensitivity. It's obviously a big issue. I think Michael felt that on his visit. They're very concerned about how outsiders work with them. So, presentation addressed that really well. My background's not wastewater treatment at all, so I've got a page worth of questions, but I don't want to take that much time. I wanted to ask you one in particular, because I think it's concern, particularly when you start talking about the potential for use of wetlands as treatment. There's a couple issues. One is the hospital for both the Cheyenne and the Crow is located in Crow Agency, and presumably the lagoons and the wetlands treatment would be downstream of whatever infiltration might come from that hospital. Did you consider the type of effluent coming from the hospital in particular, blood and other things that might be an outflow from the hospital, in considering the use of wetland treatment or that sort of thing? Before you answer that, I guess my other question with regard to the wetland treatment in particular is, in May of 2011, the Little Bighorn flooded, and it's not expected to be an infrequent occurrence. In fact, it flooded to the extent that parts of the reservation were completely isolated for 7 to 8 days, and obviously affected their water quality that they had some issues with. So maybe you can address those simultaneously, or just one answer that you can provide for both of those questions.
Sure. So as far as the wetlands go, I think we're going to be looking at several combinations of the disinfection technologies and treatment technologies. So one possibility in that could be having a disinfection and then flowing into the wetland. I think that might take care of what you're referring to.
And I guess to address the flooding, we did not really consider that as of now. We were hoping to maybe use their current system that's already in place, which is in the flood zone.
Other than like snow and whatnot, due to wetlands or sort of the open kind of treatment options?
So there have been concerns about wetlands being able to function in really cold weather, but studies have been done showing that it is possible.
Also, to add to that, it just decreased the activity of like the microbes that break things down. So it would just maybe not break them down all the way.
I want to say that's why we're concerned with the current treatment system, because the open lagoons really don't have any way to address that, freezing or anything. And so a couple of our alternatives tried to address the issue of covering them and maybe keeping it heated at each process.
Do you guys know the size of your treatment plant? What you guys know
We do not know that currently. We're trying to obtain that information.
From what we've kind of gathered, it's around, we think it's about 250,000 gallons a day, which is relatively small. But again, it's kind of, with the tribe, it's sometimes difficult to get information. So that would be one reason why it's important to stay in contact with them.
So what's the population? So given the population, could you estimate the flow if they don't have that data?
So actually the population is a little bit difficult to estimate also. Current estimates are around 2,000, but it's kind of interesting. When they did the census, I think it was in 2010, they estimated around 1,500, but their kind of thought behind it is that they're not reporting everyone that's living in each household, so it could be quite significantly off from that.
Their population actually fluctuates a lot. People come into the community on given days, and they also have a large fair once a year.
So designing to accommodate those fluctuations will be important.
What kinds of reuse opportunities are there for water reuse? Is there like industry or agriculture? What do you think about the water target might be?
Okay, so there's actually, they saw a huge coal deposit there, and they signed over land for this company to come in and mine coal, and they also have a lot of natural gas, like drilling and fracking, to my understanding. And so we could treat it to what those industries actually need. Or we could look at it because they have a lot of agriculture and ranching, and they grow a lot of sugar beets and alfalfa, which is used to feed the cattle. And also they have a bunch of wells on the reservation, so groundwater recharge would also be another option. We want to have to build as many distribution systems for that, which would be kind of the benefit of that.